Welcome to the Scientific Montessori podcast, where we translate the latest academic research into Montessori-aligned practices and share insights to make parenting dramatically easier. This episode brings you the audio version of our article, Development of the Hands and Language. To explore more articles, visit scientificmontessori.com.
Today's topic is language development. In Montessori education, brain development and language development are understood as connected. The basic idea is to prepare the environment according to this development. For example, the sensitive period for spoken language, introduced in the previous issue, begins at 7 months of fetal age, around 26 to 28 weeks of pregnancy. And the basis for this is that myelination progresses in the brainstem during this period, and the fetus's auditory function begins to work in earnest. That's why we're encouraged to talk to the baby in the womb.
Right. What's the most important thing for language development in ages 0 to 3?
What I realized when learning Montessori education is that the sensitive period for order forms the foundation for language acquisition. Around age 2, children become sensitive to set ways of doing things, routines, and things being in their designated places. I think these become the foundation for naturally understanding and using the rules in language, too.
So, what is language for humans?
It's what we speak and write.
For ages 0 to 3, very few children communicate through writing, so I think body language and spoken language are what we mean by language during this period.
That's true. Crying, laughing, pointing. Even babies try to communicate their intentions, and while they look at picture books, they don't focus on the text.
Right. When we talk about language, it can actually be divided into body language, spoken language, and written language. Body language is something we become able to use somewhat instinctively. After that, we acquire spoken language, then written language. Language ability develops in that order. This order probably doesn't change for any language.
I see. So you can listen and speak before you can write and read.
It's so obvious that no one thinks about it, but I think understanding this is fundamental to language development. Spoken language is acquired first, then written language.
Right. What changes when you're aware of this?
For example, during the 3 to 6 age period when written language is being acquired, children make mistakes like spelling said as S-E-D or night as N-I-T-E, writing words exactly as they sound. If you understand that written language is acquired after spoken language, you don't need to correct these mistakes.
What do you mean?
They're just writing down spoken language. They're in the middle of acquiring written language, so you can leave it alone. For example, even if a child says spaghetti instead of spaghetti, it will naturally become spaghetti without adults correcting them. Correcting them each time only damages the child's self-esteem, so I'd like to leave them be until they self-correct.
Right. In Montessori education principles, too, the idea is that all errors should be noticed and corrected by oneself. However, there is the point that adults shouldn't imitate Pischetti just because it's cute. They should speak correctly.
So serious. Don't think about it so seriously. Just try to make conversations more fun, right? It's a one-time thing, that period.
I didn't talk much with my parents, and at school I had little time to talk freely, so my vocabulary's poor and I can't make my stories interesting.
So, about human language acquisition, when we look at Homo habilis fossil skulls, we can see that Broca's area is prominent. Broca's area is the part of the brain that controls speech production, located in the left frontal lobe. It's called the motor speech center. It's named after the French neurologist Broca, who reported cases of aphasia in patients with damage to this area. When Broca's area is damaged, you can understand the meaning of spoken language and have an idea of what you want to say in response, but you cannot put what you want to say into words. Speech isn't very fluent, and rhythm and stress become inaccurate.
How is this relevant?
We know that Broca's area is a brain region related to language, speaking, and writing, but interestingly, as the term motor suggests, it's also activated when moving the hands with intention.
So it activates even when doing craft work silently without using language?
Yes, brain regions including Broca's area are activated by hand movements during work and by observing one's own hands. It's not just a speech production center. It's involved in understanding the meaning of hand movements and in verbalization without speech. For example, when observing piano playing hand movements, Broca's area activates when viewing unfamiliar melodic movements.
How should we interpret this?
Essentially, this is probably a region for understanding hand movements, and as this region develops, we become able to speak words as well.
I see.
Anthropologically, Homo habilis was the first human species discovered with stone tools, called Odoan tools, simply chipped stones. They're said to have used these to scrape meat from animal carcasses. Besides stone tools, sticks have also been excavated, showing they made and used tools. By the way, Homo habilis means handyman.
So Homo habilis used tools and also spoke?
It's thought they couldn't speak. There are various theories that speaking began with Homo erectus. Since sounds can't be excavated, we can only estimate from archaeological evidence. When analyzing Homo habilis skull fossils, as I mentioned, the Broca's area in the prefrontal cortex shows a bulge, so the beginning of human language development is thought to have started there. In any case, there's a flow. Hands develop, tools are made, speech becomes possible, hands develop further, tools develop, and speech becomes more refined.
We now know that birds also have language and grammar, but do birds have a brain region corresponding to Broca's area? Birds don't use hands, so how did their language develop to the point of having grammar?
Birds' wings are arms, right? So if we include arms as hands, I think a Broca's area-like region probably activates when flying. If birds learn to fly through observation and imitation, the logic of language development might be the same.
Looking into it, birds do acquire flight through observation and imitation. Also, regarding tools, New Caledonian crows use wooden sticks to get insects and combine parts to make tools. And it seems birds do have brain regions corresponding to Broca's area. Broca's area is included in what's called mirror neurons. Those capable of learning through imitation include primates, including humans, birds, and cetaceans, which have mirror neurons. It seems that if you have language, you definitely have mirror neurons, but having mirror neurons doesn't necessarily mean you have language.
I see. What I thought about with the mirror neuron discussion is that for humans, being able to imitate hand movements seems to have a major influence on acquiring spoken language.
Right.
This is at the hypothesis stage, but there are research reports that ASD, Asperger's syndrome, shows structural characteristics in Broca's area that differ from neurotypical individuals. Personally, I suspect it's a language area issue.
If we consider that mirror neurons don't function well, the symptoms reported in ASD do make sense. Not being able to empathize, not being able to understand others' emotions, and so on.
Empathizing, understanding emotions, understanding intentions, motor imitation. These are gifts of mirror neurons.
I'm aware that I have ASD, and it's interesting to start understanding where the problems might have been in my early childhood.
Sesame Street, children's TV shows, hand play songs. In a sense, they're developing Broca's area through imitation of hand movements.
There's a photo of a baby macaque imitating a human sticking out its tongue, and apparently this is only seen for a few days. In other words, there's a critical period. There might be a critical period for the human Broca's area, too.
Right. That's why the environment from ages 0 to 3 might influence one's entire life.
In Montessori environments, we do what's called a presentation, showing hand movements slowly so even small children can imitate them. By showing hand movements slowly, even 1-year-olds can dress and undress, cook, clean, and do laundry.
So moving your hands slowly is important. It's activating the child's Broca's area. Also, Broca's area is the region for verbal communication, located in the left prefrontal cortex. Symmetrically, brain science research has revealed that the right prefrontal cortex is involved in nonverbal communication, understanding emotions from facial expressions and such. It's been found that children's prefrontal cortex is highly activated when talking with parents, but when talking with unfamiliar people, the right prefrontal cortex isn't activated as much. By the way, it's known that in ASD, the left-right network structure of the brain is asymmetric. From this, I infer that very early daycare use might contribute significantly to ASD.
I was put in daycare before age 1, so this hypothesis concerns me greatly. And the difference in prefrontal cortex activation between parents and strangers is shocking. This scientifically demonstrates the importance of time spent with parents and reading aloud to children.
Thank you for listening to the Scientific Montessori podcast. We hope today's episode helped you see how research in Montessori principles can make parenting simpler and more meaningful. For more articles and resources, visit scientificmontessori.com and join us again next time.